Hello, this is Group 10, and I'm Jason.
May.
And I'm Chiamela, and this is our Twitter data sentiment analysis project.
So, the motivation behind the project. Reviews, surveys, and tweets have become popular ways for customers to express their opinions and companies to collect feedback. Some of their motivations include wanting to use social media as a lens to view customer sentiment and understand the impact, and as well as using the research in different, as well as our research is different because we took neural tweets into account. Uh, When it comes to personal motivations, mine is I wanted to undertake this project because I think social media sentiment analysis is something I could have never imagined was possible just 6 months ago. Therefore, I'm fascinated by the possibilities of this kind of work and wanted to use this project as an introduction to the field.
Personally, I took interest in this topic because, as a person who uses social media daily, it's interesting to see what we post on social media has a greater effect on the quality of goods and services that we receive. I've also noticed an increase in like surveys and reviews, and I couldn't see how machine learning made analyzing that data is easy for companies. So doing this project gave me much insight into that.
And for me, I'm interested in know how the social media data can affect people's daily choices and maybe affect the society. In this presentation, we will focus on the three topics. First, what is the sentiment analysis? And describes the techniques we used and show our current outcomes. So, what is sentiment analysis? Sentiment analysis is a form of natural language processing known as NLP that allows us to detect positive or negative feelings in a text. It focuses on the polarity of a text, but it also goes beyond polarity to detect specific feelings and emotions, such as angry, happy, sad, and urgency, and even intentions.
So why is sentiment analysis important? It's becoming like a fast, essential tool to monitor and understand sentiment in all types of data. It's used to automatically analyze customer feedback and allows brands to learn what makes their customers happy, frustrated, so that they can tailor products or services to meet their customers' needs. Some of the benefits of it include like sorting data at scale. These companies have like thousands of tweets, thousands of data to go through, and they cannot process that manually. So sentiment analysis allows those businesses to process those huge unstructured data in an efficient and cost-effective way. We also have real-time analysis. For example, if there's a social media post that's causing a lot of controversy, sentiment analysis models allow companies to identify that specific post, those specific situations, and take action right away. There's also the benefit of consistent criteria, which by using centralized sentiment analysis system, companies can apply the same criteria over all their data and improve their accuracy and gain better insights on their customers.
So, there are three types of sentiment analysis algorithms that we use or we will look at. So the first one is rule-based, and with rule-based, you use minimal set of rules. Examples include stemming, tokenization, and lexicons. The second is automatic, which uses machine learning techniques to form the data, to learn from the data. In this, it performs feature extraction followed by classification. The third is hybrid, which uses both rule-based and automatic, often more accurate. So with rule-based systems, they are very naive since they don't take into account how words are combined to a sequence. Of course, more advanced processing techniques can be used and new rules added to support new expressions and vocabulary. However, adding new rules may affect previous results and the whole system can get very complex. Since rule-based systems often require fine-tuning and maintenance, they also need regular investments. The first step in learning text classifier is to not form, but transform the text extraction or text vectorization. New features extraction techniques have been applied based on word embeddings, also known as word vectors. This kind of representation makes it possible for words with similar meanings to have a similar representation, which can improve the performance of classifiers. And then classification using deep learning artificial neural networks. Hybrid systems combine the desirable elements of rule-based and automatic techniques into one system. One huge benefit of these systems is that results often are more accurate, and thus we use hybrid.
And we'll talk about our approach. Here are the techniques we used in our project. We used the word-to-vector to represent each word as a sequence of numbers. We also built RNN, LSTM, and stacked LSTM models, and we will compare their accuracy.
Okay, we're going to look at word-to-vec. So each dimension represents a meaning, and then word's numerical weight on that dimension captures the closeness of its association with into that meaning. For our project, for instance, if you take the given word good, you can see that it's higher classification score in some instances rather than others. Model accepts a single word as input and attempts to predict the probability that a randomly chosen word is close in meaning to the input word. Therefore, the model would hypothetically accept the word good as an input and attempt to predict the probability that a randomly chosen word is close to the meaning to the input word.
So RNN, recurrent neural networks are deep learning models that capture the dynamics of sequence via recurrent connections, which can be thought of as cycles in a network of nodes. So in our case, we're using many-to-one RNN, which specifically works for sentiment analysis. So the input is expected to be a sequence of words or even paragraphs of words, and the output can be a regression output with continuous values, which represent the likelihood of having a positive sentiment. The main function of RNN is the processing of sequential information on the basis of internal memory captured by different cycles. It's difficult to train RNN to capture long-term dependencies because of vanishing gradients, which is why we implement LSTM later on in the project. So the input layer X takes the input to the neural network, processes it, and passes it to the middle layer. The middle layer consists of multiple hidden layers with its own activations, functions, weights, and biases. The recurrent neural network will then standardize the activation functions and weights and biases so that each hidden layer has the same parameters. Then, instead of creating multiple hidden layers, it will create one and loop it over it many times as required.
So for the LSTM, it's known as long short-term memory networks. Our special kind of RNN capture of learning long-term dependencies. And as you can see from the figure, LSTMs have cells in the hidden layers of the neural network, which have 3 gates, an input gate, an output gate, and a forget gate. These gates control the flow of information which is needed to predict the output in the network. And the reason we choose LSTM for our project is because it has long-term memory compared to RNN, which can only learn about recent information. LSTM can help solve this problem as it can understand context along with the recent dependency. Since we are dealing with twists, like a sentence, so we need to memorize the previous words and understand the context in order to get the sentiment. Therefore, LSTM's ability to understand context is very useful.
And then we have stacked LSTM. The stacked LSTM model is an extension to the LSTM model with multiple hidden LSTM layers. In this, where we have each layer contains multiple memory cells, and the stacked LSTM hidden layers make the model more deeper and much more accurate. And then we have our outcome. So the outcome is the results of the models applied.
Okay, so these are our related works. We have the titles of each paper displayed on the slide. So for our first paper, some similar works which we did is where a team of researchers conducted a sentiment analysis project that looked over sentiment data from Twitter users who traveled by 10 different airlines in the Middle East. The researchers created methods for text mining. They analyzed customer opinions, focused and categorized them, then evaluated the customer satisfaction. Once they completed this task, they then provided recommendations to the different airlines on how they can improve their customer experiences. The second paper, applying deep learning models to Twitter data to detect airport service quality, involved using a Twitter data set as an English model and an RCenti data set as an Arabic model to measure airport service quality. The researchers built a CNN and an LSTM model, trained them separately for both the English and the Arabic data sets, and then they performed word embedding, tweets clustering, and compared the accuracy and F1 scores between each model. Their results showed that the LSTM model was slightly better than the CNN for detecting sentiment, and proved that LSTM is also effective for short tests like tweets. The final related work we reviewed was the airline tweets sentiment analysis using RNN and LSTM techniques. The researchers used a Twitter dataset from airline customers and built simple RNN and an LSTM model to perform sentiment analysis. They applied various types of LSTM models like stacked LSTM to better classify the tweets, and they achieved a 90% accuracy with the LSTM model, which they concluded that the LSTM model, especially stacked LSTM, did better than the RNN model.
And here are some accuracy we collected from the related works. Most of them use LSTM model, and the accuracy is above 80%. One research also built the stack LSTM model and reached 91% of accuracy. From our review of related works, our expectations for our project was to have stacked LSTM with the highest accuracy, followed by LSTM and RNN. However, in our analysis, we discovered that it was the opposite, with stacked LSTM being the lowest and RNN being the highest accuracy.
To piggyback up what May said, we're going to talk about the accuracy of the results. As you can see, the RNN has the highest accuracy score, which is marginal in comparison to LSTM, while the stacked LSTM is the results are not necessarily the best. However, we plan to work diligently to not help, but we plan to work diligently in order to improve the RNN, LSTM, and stacked LSTM in order to hopefully match the results of the related works.
This is our team and our various contributions. And thank you for listening. And we want to open the floor for any questions that you may have. Bye.
Bye.